You're welcome.
Hi, everyone. I hope you hear me. So let's get acquainted. Today we're going to talk about safe stack and a couple of words about me. My name is Mikhail, and I love F#. That's basically everything you need to know about me. Well, of course, I can add that I'm a software developer, mainly .NET developer. But let's better talk about you. Who works or tries to use F#? OK, not that many people. Here I'm not trying to sell you functional programming, as we're already here. But I will try to sell F#. Who works as a full stack developer or considers himself as a full stack developer? OK. Or backend? Front end? OK. Nice. So with safe stack, I believe you will find it much simpler to move to full stack development if you really need that. So first of all, about F#. F# is a functional language with a lot of useful features as required for the functional language. It has immutability. It has great pattern matching thanks to static typing and the algebraic type system, which allows very simple and clean domain-driven development. Scott Vloshin wrote a great book about it. If you read this one, you don't need to read the one from Eric Evans about domain-driven design. He also wrote recently an article about why F# is in enterprise is the best enterprise language. Highly recommend to open F# for Fun and Profit website. He's the creator of this website. It's an awesome source about F# itself. So more to that, F# runs on many platforms, including Windows, Linux, and macOS. I believe on different architectures of processors. Thanks to .NET Core, I believe that's the greatest reincarnation of a framework. Full .NET framework worked only on Windows. Now we have all platform support, and it's much more performant and lightweight. F# is also great for as a single language for full stack development. That's thanks to Fable. We'll talk about it in a moment. And the last but not least, F# has a great and a really awesome community. We love to share the knowledge, and there are a lot of people involved. Thanks to them, all the credits. So let's talk about safe. Safe is not something special. It's not a specific implementation of something. It's just a set of tools which you can use, all of them, or just some, or one, doesn't matter, or you can replace one part with another. But the main focus is type-safe development. Type-safe, since it's F# all the way down from the server to the cloud, from the server in the cloud to the front end in the browser. So it's an abbreviation which stands for Saturn, Azure, Fable, and Elmish. Let's go to Saturn directly. Saturn is a web framework, the server-side web framework. And basically, as everything in Safe, it doesn't implement something new. It doesn't reinvent the wheel. It just makes an abstraction over something already existing, like Giraffe. Giraffe is an abstraction over ASP.NET Core, which makes object-oriented imperative ASP.NET Core C# basically project. It makes more functional, and Saturn makes it even more declarative. It also has some built-in features like libraries like Dapper and simple migrations, which help with the database access. Dapper is a object mapper, and simple migrations is a simple tool for database versioning. But you don't have to use them. You can use type providers, SQL providers, whatever you need, or none of them. And as I told you about Safe, you can just replace Saturn with alternatives like use Giraffe directly, or ASP.NET Core, or Suave. It used to be the recommended web framework in Safe stack. One great thing about Saturn or even Giraffe is that it doesn't hide the underlying system like ASP.NET Core. It doesn't hide it from you. If you really need to fall back deeper to that and customize it somehow, you can do that easily with no issue. Even deeper to the Kestrel is a web server under the hood of ASP.NET Core. Saturn might, some abstractions from Saturn might be familiar for those who work with Elixir, or Elixir's Phoenix framework, like application, scope, which is called router here, or controller. Saturn has its own .NET template and CLI tool. So with just a couple of lines of in the console, you can generate a lot of boilerplate code, like the one with books. You can see it will generate a controller, a view, a model, a migration, a database access layer. Everything is done for you with these properties like ID, title, and author. Then you can customize it as you wish. It also utilizes the view engine of Giraffe. Might look familiar to Elm markup. Anyone heard about Elm? Okay, so the syntax will be familiar to you with square brackets, like the DSL instead of HTML. The next letter in SAFE is A, which stands for Microsoft Azure. I don't think I need to present it because it's one of the three well-known cloud providers. As an alternative, you can use Amazon or Google platform, or any other hosting actually, or just use premises, bare metal, whatever you need. Safe works really well in Docker. Microsoft provides official images for .NET Core, which actually even runs on Alpine Linux. That makes it much more lightweight and simple. So let's go to Fable. From my point of view, Fable is like the key technology in Safe Stack, which first of all, this one makes Safe Stack as full stack development tool chain. Fable is an F# to JavaScript compiler. Here, we can consider JavaScript as just another runtime for F# as .NET CLR, where the F# compiler compiles it to the intermediate language, and then .NET executes it. Here, it's very similar. Fable compiles it to JavaScript, basically to Babel AST, and then Babel, with the help of Webpack, it creates a bundle, and the browser just executes it. It has very simple interop with JavaScript. There are a lot of bindings. You can use Fable even without any framework or view library like React.js, which is the most common view library for Fable. You don't have to work directly with JavaScript. There is also a great tool called TS2Fable, which allows to generate Fable bindings for JavaScript functions, for JavaScript code, depending on TypeScript definition files. So TypeScript is static typed language, and F# is the same, so there is just a tool which converts one to another. And one more great thing about React in Fable is that you can have server-side rendering without Node.js. So it's F# all the way down or up. Everything is in F#. By the way, there is a set of bindings created by me, Fable Material UI, which allows you to write even CSS in F#. So you don't use anything except F# at all. Like no JavaScript, no CSS, nothing, just F#. There is an alternative to Fable as WebSharper. It's an old Sharper project, which is not only for F#, also for C#, but let's skip it. Just to recap, F#, Fable takes F#, creates a Babel AST, and then Babel creates the ECMAScript 5, which can be executed in any browser, even not in the most modern one. Elmish. Elmish is an F# implementation of Elm architecture. I saw many of you are familiar with it. So it's a model view update architecture. With the help of Webpack dev server, we can have even hot model replacement with it. So you don't, if you, for example, if you are testing something in your application and you made 20 clicks to get to some point, and then you change something in the code, Fable generates JavaScript. It is compiled, pushed back to the browser, and you see the changes without the change of the state. You don't need to click that 20 times again. I don't know, maybe for many of you it's not something new, but just briefly, model view update has model as just pure data, which is rendered by some view function, absolutely pure function, then passed to the user in the browser. In the view, we could have, for example, I don't know, a button click which issues a command, and that one is passed to mailbox processor as the only impure thing, the runtime of all this cycle, which deals with side effects and passes a message to the update, another pure function update, which has two arguments, model, the current state of the model, and the message. And creates a new model based on those two arguments. Again, it's pure, and it can also issue another command, which will be then processed by the mailbox processor and pushed back as another message, possibly to update. And this cycle goes infinitely. With this, you can have time traveling, because every message is an event, and if you replay those events, you end up on the specific state of your application. To connect everything together, the server side and the client side, you can use HTTP requests, like raw, usual HTTP requests with HTTP verbs like get, post, put, delete, whatever. For example, with the help of fetch, we have bindings for Fable for fetch. But there are better options, like Fablemoting. It's a great library for hiding all those HTTP raw requests details, and then you work with it just in RPC way, like you just call a function. For you, it's just a function. It's not a request. You don't need to bother about the routing, about HTTP headers. I don't know, some verbs again, get, post, whatever. Everything is done for you. For you, it's just a function, and you call it. I gave a talk about Fablemoting at Meetup in Prague. You can find it in YouTube. There are more details about it. And the second good thing, a good library, is Elmish Bridge. This one utilizes the WebSockets, which allows you bidirectional communication between client and server. But of course, there is a drawback because it's stateful, and you have the connection. And if you, for example, redeploy your server, restart it, the connection is lost. You need to handle it somehow. But if you need to push something like real time to the user directly from the server, Elmish Bridge is the way to go, definitely. Safe has a template for .NET, so you can just create a new project with one line in the console, and it has several prerequisites. First of all, it's .NET Core, probably the latest version. It catches up pretty quickly, so nowadays it's 2.2, and the version 3 is in beta or in preview even. Node.js, Yarn or NPM is a package manager. Fake5 as a .NET Global tool. Fake5 is a DSL for building your applications. Basically, you can just write one script, again, is in F#, is a script language. You write one script and use it in any CI system everywhere you want. Everywhere it will be just fake build, and that's it. If you're a Mac OS or Linux user, you might need Mono for F# REPL, but everything else, I believe, now works without it, just on .NET Core, on cross-platform .NET Core. This is the short list of possible options in Safe Template. You can choose from which server framework you want to use, either Saturn by default, or Giraffe, or Suave. You can choose, for example, a communication layer like remoting. There is also such thing as Fulma. Fulma is a wrapper binding for Bulma. If you heard about Bulma, it's a new kind of alternative for Bootstrap. It's lightweight and JavaScript free, only CSS is involved. So SafeStack provides several layouts for Fulma, like, I don't know, landing, admin, hero, and several others. You can choose which kind of deployment you want to use. Azure, Google Cloud, and Docker. I believe that's the whole list for now. And you can choose NPM or Yarn as package manager. So let's have a look at some demo. I actually wanted to show you one application which I wrote on the way here. So let me just switch to where is it? Which one's I will stop it. It's already running, but I will stop it. Yeah. Clear. Do you see anything, or should I switch to black, like dark theme? Dark theme, color theme. I prefer this one. It's better. Okay, let's try. So in any safe project structure, we have, let's have a look. So we have basically three parts: the client, the server, and the shared part. Thanks to F#, everywhere we have some shared code. We can have some shared code. So let me firstly run the application, and then I will show you how it looks like. It's now compiling the JavaScript into F# to JavaScript, and then Webpack tries to get all those dependencies from node models. And this is what we have. It's not, doesn't fit, but okay. I made this small project for searching the cocktails. I don't know if anyone likes cocktails. We can search for a cocktail. Let's say margarita, and here we go, the list of possible margaritas. Then we can open one and see how to make it and which ingredients it has. This project is written purely in F#. You can see here that, hopefully you can see here that 73% of code is written in C# and in F#, and 23% is written in JavaScript, but this is Webpack file only, nothing else, and Webpack is just a configuration for your bundling. There is one HTML file and a very small amount of CSS just for HTML and body selectors. So let's get back to the project. You can see here that the root changes. So now it's search as a home page, and if we go to some cocktail, it changes to the cocktail and its ID. Here I utilize the type provider for JSON type provider for accessing the public API. So I don't have my own database for it. It's just a direct communication with API. And the great thing with type providers, you don't need to write the models which you get from the API. You don't need to define that, for example, a drink has a name and the recipe and everything else. You just say that in this URL, I have the data. Please create a cocktail details provider depending on this URL. And then I will just call it. And I will call it this way. So I run async load with the details and the ID. And I get the drinks. And it is statically typed already. Everything is done for you. So you can see that the output of this API endpoint is an object with drinks property. I have it. I haven't written that. It's just generated for you automatically. And for example, here you can go deeper and see all the properties of that drink, like the ingredients, the name, the category, the alcohol, the everything. Everything is generated for you, so it simplifies and makes your development much faster. You don't need to define all those models and how to combine them. Everything is done for you. And I have the same for the search URL. It basically has the same approach. The output of that endpoint is actually the same or similar, so you won't see much of a difference here. But that's the simplicity and the power of JSON, all type providers. There are type providers not only for JSON, for CSV, for HTML, for SQL, and more and more, and for Azure. Some Azure services like databases, I believe even for Cosmos DB, something, or Azure storage for sure. That's about the server side. Also, the server side, well, let's skip it. Application, I hope you see it. Yeah, this is how my application on the server side is defined. basically that's it. I mean that the whole configuration is here. I use some address with a port, which is taken from the environment variables. It says that we should use gzip and memory cache, and we can have some static files from the public path, and we use router. And for router, we use just Fablemoting, which hides everything from you. You don't even need to bother about the routing itself. In the shared part, we have our definition of our API. Sorry, it has just two functions: so search and details. One takes the keyword and outputs the result of cocktail list. And another takes the ID and outputs the cocktail details. Optionally, it might be not found, for example. And we have these models actually here. So this part is shared between the client side and the server side. Server side then implements that. But what do I mean by implement? The cocktail API is a type, so we create a value of that type, providing that for search we will use this function, and this function, you've already seen it, it's this one. And that's it. So we create an HTTP handler from that and pass it to the application router configuration. That's it. That's everything we need for server-side implementation. And you can see that there are just a couple of lines of code, and after writing them or just using the predefined template, you can focus on the business logic to write the real logic, which really matters, not dealing with all those configurations like which HTTP verb to use. Let's debate either it's post or put, whatever. Just write the logic. That's what we need to be focused on. And on the client side, we then use that type of our API, which is just a type. We create a proxy for it. And then in our application, we use it as just a function. So you see here, we run it. We have the same function. It's search. It's absolutely the same function, but it's on the client side already. But it's still type safe, absolutely statically typed. Everything is checked. And under the hood, it makes the HTTP request. You don't think of it. You just use the function. Give me the data. Yes, it's async, so you need this match with the exclamation mark. And with the result, either it's OK with cocktails or some error, and we can output the error. Then now, this is the client, the update function, which I mentioned in the model view update architecture. So it takes the message in the current model and outputs a new model depending on these two parameters. So for example, when we have the keyword changed in our field, we output a new model with the keyword changed to the new one. And there is no need for a command, so we don't output that. We actually have this cmd none, which is the alias for empty array, empty list. So it doesn't matter. When we want to search, we can. We don't need to change the model. For example, we want to send the request, so we issue a command of async. Our search cocktail function is async, gets the data and outputs it. Then we pass the parameter, and we have how to deal with the result. Either it's success or a failure. And these are actually also messages which will be outputted with the mailbox process with the runtime, which, as I showed you. It's just another message for the loop. And in the view, yeah, this is the high level of the view function. So I just check which page we are at, either search or cocktail. And I output the corresponding page depending on that. It's either search page or fragment with the details. In the components, I can show you that here, for example, search result, I use the CSS properties directly here, but don't be confused. It's not the inline styling. It generates the CSS class and puts it into the head HTML tag in the page. So it works as it should with the CSS, and it can be reused, of course. So there is no need for inline styling or and you know the inline styling are really bad. Like so you can Fable with Fable Material UI allows you to write CSS in F# as well. I don't know if we can change something. I would also, you know, we have 4 more minutes. Let's do one thing. Let's create a new project. Actually, let's create a new project. Make save demo, save demo.net new save, and let's say we want to have, or let's just make the default one. Let's see if I can run code from here. Yeah, okay, cool. So as you can see, it created the same project structure with the shared part, with the server and the client. Let's try to run it. I believe it should be build run. It now gets all the dependencies. Here we use Bucket, not Nugget. It's a dependency manager for .NET projects. You can use it with C# projects as well. I highly recommend it because it has much more features than Nugget, and it's safer to use Bucket with log files and precise control on the dependencies. And you can choose from storage, whatever. But it's not a part of this talk. So if you have some interests, just try. Okay, so we have the application. I don't know if you can see it well. So it's the counter, basically, very simple counter. If I click plus, it manipulates the counter up and down. So good thing about it, you can see, for example, let's say we have 55, and then I want to change something on the client side. Let's say I want to change some text. Let's say it will be not save template, it will be save demo. So you can see on the bottom that it's being compiled again. Now it's compiled. And you see that here we now have save demo instead of save template, and the value is still the same. So this is the hot model replacement. You don't need the application state is not changed. 55 is still 55. And it's not only about the small changes like text. You can really change the logic, and it will replay all those messages to get to the same state, which I believe can be checked even in the Redux tools, but I'm not sure if I have them installed on this laptop. I believe not. So Sorry for that. I don't have them. In the Redux tools, you can check everything. So basically, guys, that's it. I would say that. Oh, okay. Sorry, we have this. Yeah. I don't. Do I have time for questions?
We have a couple of minutes for questions. Does anyone have any questions? Okay. You.
For .NET developer who wants to write web projects, it's still something to learn. Fable, which runs on .NET Core, and learn maybe Fulma or other alternative CSS framework. But what about Fable versus like Elm? Do you see some principal advantages for a guy who is already doing backend .NET development, doing things in Fable versus that if people just use plain Elm, which is comes with like in the box with a lot?
Well, that's the thing. Elm doesn't have that great interoperation with JavaScript. Actually, if you want to use some third-party JavaScript library, it's a bit painful. If there is no package for Elm, you need to either write it by your own or I don't know. It might be painful. And with Fable, you either generate the bindings with TS to Fable. That's super simple, or you can just use it dynamically. So Fable provides APIs for dynamic typing, let's say. So everything is an object for you, but in JavaScript, we all know that any object can become a different type of an object easily. So Fable allows that. And plus, Fable is not, since it's F#, it's not pure language, and there are some advantages, as you talked about it as well.
Okay, thanks. Anyone else? Okay.
Thank you for your talk. And how do you debug client-side logic? Do you debug it in a F# side or JavaScript?
You debug it in F# code, and actually SafeStack provides the config for VS code. Like you can debug client side, and it will automatically debug it in the VS code directly. And the same works with the server. So you don't even switch to another application onto the browser. I mean, everything is in one IDE, and that's pretty cool.
I've seen one and more. Okay. No? Okay. You're welcome.
Does it also goes with time machine debugging the same as Elm?
Yeah.
Yeah?
Yeah.
You can do that? Okay.
Yeah.
Anyone else? No? So I have one last question. When you answered the first question, you said that Fable has side effects and Elm does not have them, and you said that this kind of enhancement. But what's the benefit of it if all the main feature of the Elm architecture is making it side effectless?
Yeah, I just meant that F# itself could be not pure, and sometimes it's hard to sell pure functional development to the people who don't know anything about it, or at least don't use it. Like my main colleagues from .NET world, they work with C# is absolutely impure and imperative, and it's the transition to client side with Fable is much easier than to Elm, because it's just completely opposite paradigm, It's
but when you say that it has side effects, and then you say now we are making the Elm architecture and it does not have any side effects, that this kind of lie when you say that Fable has side effects, right?
I just said that you can have side effects in F#. Fable itself is just a compiler, and you can use pure architecture and write pure code, but it also allows you to write impure code. Elm doesn't do that, right? It's pure language like Haskell, right? So you cannot even try to write any impure code. I don't say that's a benefit for the development itself. It's better for transition to, you know, this approach, like step by step.
Okay, thank you so much.
Thank you, everyone.
That's it.
Find me on Twitter. Yeah, thank you.